Okay, so Miss Lewis is having a party. Hey. She is renting each lawn chair for $2 an hour. I'm going to let chairs be X and tables be Y. So that means my equation is 2X plus $4 an hour for each table, so plus 4Y. Her budget is at $32. So that means I can't spend more than that. I have to spend less than $32 on these chairs and tables. So that's one inequality. I want to have at least 4 chairs. Remember, we said chairs are represented by the letter X. So I'm going to have X, the number of chairs, needs to be at least 4. Do you guys remember what symbol we put for at least? A greater than symbol. That should be in your notes. So I would like more than 4 chairs. Okay, so we're going to go ahead and graph what this looks like. I'll do this bottom one first. That's easy. I'm going to go to X. So this is the X-axis down here. I'll put it here. This is the X-axis here, and this is the Y-axis here. Okay, so the X value 4 is right here. This is the line that goes through 4 on the X-axis right here. So that's the line you should have drawn. What side is greater than 4? To the right, because this is numbers like 5, 6, 7, 8. So I'm going to shade this side. I want at least 4 chairs. So that's this side of the graph. Okay, now we're going to have to do some algebra to graph this equation. So I'm going to move this 2x to the other side. So I'm going to have 4y is still on the left-hand side. I have my symbol, but I'm moving 2x to this side. So it will become a negative 2x. And the 32 is still positive. Now I'm going to divide everything by 4. I did not divide by a negative number, so this sign will stay the same. You only flip the sign when you divide by a negative. Okay, let's simplify this. Negative 2 over 4. I can divide both the numerator by 2 and the denominator by 2. So this will be negative 1 over 2, a half. 32 divided by 4 is 8. So this is the line that I'm going to graph. So I start at 8. That is your y-intercept. So here's 1, 2, 3, 4, 5, 6, 7, 8. I start here, and from my y-intercept, I go down 1 over 2. Down 1 over 2. This is my line. Now, this is a less than symbol. It looks like an L, less than or equal to symbol. So I'm going to go down from my line. The double shaded region is right here. This is the area that is shaded twice. That is where your solutions are. So for example, let's say I pick a point right here. That's the point 7, 2. That means I can buy 7 chairs and 2 tables. You can pick any type of combination in the double shaded area. Because if I do 7 chairs, that's at least 4 chairs, so that works. And 7 times $2 is 14, and 2 tables will cost 8. And that's within my budget. So any point that you pick in this double shaded area will work. Okay, let's try number 2. It says Mr. R is selling fan apparel for the football team. He sells t-shirts for $5. I'm going to let t-shirts be X and hats be Y. So you should have 5X and $8 for each hat. He would like to make at least $40 today. What symbol should I use? Greater than or equal to. It's always opposite. He only has 9 hats to sell. So hats is represented by Y. So he could sell only has 9 hats. He has to be less than 9. He can't sell 10 hats or 11 hats. He only has 9 to sell. But he can also sell less than 9. It's not guaranteed that he's going to sell out. Okay, so we're going to go ahead and graph this again. I'll start with this one. That's the easiest. You go to y at 9. So here's the y-axis here. When I draw it here, I mean this. This is your y-axis. I should probably draw it up here. This is your y-axis. Okay, so you're going to go to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is right here. So draw a line that goes through the 9. It'll be horizontal. Okay? That's the line that goes through 9 on the y-axis. And he only has 9 hats to sell. So he can sell 8 hats, he can sell 7, 6, 5. He can sell anything below the 9. So I'm going to shade below 9. This next one, guys, is just like the previous example. You just need to solve for y. So move this over, and then you'll divide everything by 8. I'm going to let you guys finish number 2. Let's go ahead and move on to number 3. This is just some more graphing, okay? I'll just do 2 of them with you. You should be able to do the rest of these. So I'm going to do this one here. I'm going to move this 2x to the other side. So I'm going to have negative 4y, the symbol, and I'm moving the 2x over. So it'll be negative 2x plus 8. Now we're going to divide everything by negative 4. I'm left with y. This will be a half, and this will be a 2, minus 2. What happens to my symbol? Y. Why do I flip it? Yep, I just divided by a negative 4. So we divided by a negative, we have to flip it. All right, so guys, you know how to graph this. Go ahead and graph that on your graph. You start at negative 2, that's your y-intercept, and you go up 1 over 2, up 1 over 2. You can also go this direction. Draw the entire line. And what kind of line do I draw? A dashed line. It should be a dashed line, not a solid line. Okay, this is a greater than symbol, so you should be shading above. You should shade lightly because we want to see what part's double shaded. In this case, triple shaded because we're going to do 3 different graphs. Your next one, move this negative 3x to the other side. So you'll get 5y less than or equal to a positive 3x plus 5. Now you divide everything by 5. So y is less than or equal to 3/5 x plus 1. I'll go ahead and graph it in green. This is your next one. Go ahead and graph it. You start at 1, and you go up 3 over 5. And you can go the other way, down 3, this way 5. And this will be a solid line. And that's a less than or equal to symbol, so that's this way. Okay, finally, I'm going to do this last one. I'll do it in red. This is the x-axis is greater than 5. So go to the x-axis at 5. 1, 2, 3, 4, 5, right here. And you want to do a dashed line at 5. And what side of 5 should I shade? What symbol is this? It's a greater than symbol. So what side is greater than 5? Yep, the right side. These numbers are greater than 5. All right, guys, so the double shaded area, let me highlight it for you, is right here. This part is double shaded. That's the double shaded part. Okay, so let's see if these points are in the double shaded area. So I'll pick this color. No, I'll pick yellow. Okay, let's see if 10-4 is in here. Yep, 10-4 is right there. So that's a solution. I'll circle it. 8-2. 8-2. Is that a solution? Why not? Yes, it's on a dotted line. Guys, write the reason. It's on a dotted line. You need to know that. 8-2 is on a dotted line, so it cannot be a solution. 8-4, let's see 8-4. Is that a solution? Yep, it's in the part, so I'll circle 8-4. And let's see, 5-4. Let's see if that is in it. 1, 2, 3, 4, 5. 1, 2, 3, right here. Is that a solution? Yes, it is. It's not on a dashed line, it's on a solid line. Oh, wait, it is on a dashed line. You guys see this red one we just drew? Sorry, so this is not a solution. This is also on a dotted line. It's on the line 5 greater than, x is greater than 5. It's on this dotted line. So that one is not a solution. So the only ones that are solutions, guys, are this one and this one. The other two are on dashed lines. All right. Last one, guys. Let's try number 4 together. Okay, so Timbercraft Tables builds custom wood dining tables. If the thickness of a tabletop varies more than 0.5 inches from the target thickness of 4 inches, the tabletop cannot be used. Okay, so guys, let's talk about this. They're talking about the thickness of the table, okay? The thickness of the table, like the table you're sitting at, it needs to be 4 inches thick. Does that part make sense, guys? Your table needs to be 4 inches thick. It's saying that if it varies more than 0.5 inches, so if it's too thick by 0.5 or it's too thin by 0.5, then they can't sell the tabletop. Does that make sense? That's what this problem is saying. So it says, write and solve an absolute value equation to find the interval of the acceptable thickness of the tabletop. I'm going to pause here and let you guys figure it out. Okay, so let's talk about it. Your target thickness is 4 inches. You want your tabletop to be 4 inches thick. So that means x minus 4, where this represents the actual thickness. This needs to be less than or equal to 0.5. Okay, so guys, if your table, just for an example, if your table is 6 inches thick, how much over is it from the required amount? 2 inches, right? Is that within 0.5 inches? No, that's not right. What if your table is 5 inches thick? It's 1 over. Should it be 1 over? What do they want it to be over? 0.5 is the minimum. It's too thick. Okay, does that make sense, the equation? Okay, so the actual amount goes here. So I represented it by x. Okay, it needs to be within 0.5. Now, guys, let's go below 4. What if it's 3.8 inches thick? How much is it off? 0.2. Is that within 0.5? Okay, so it's a little bit thinner than we would want it, but it's not too thin, is what it's saying. Does that make sense? Okay, because 3.8 minus 4 is negative 0.2, but the absolute value of that is a positive 0.2, and that's within half of an inch. Does that make sense, guys? Okay, so this should be your inequality. And if you solve it, let's see if you guys remember from last week. We're going to create two cases. X minus 4 is less than or equal to 0.5, One case stays exactly the same. The other one is x minus 4 is greater than or equal to negative 0.5. And then you solve it. So guys, I'm going to give you guys a moment to solve it. Then you can look up here and check your answer. And once you guys solve it, give me the interval. This is what you should have gotten. If I do a number line, 4.5 is right here. 3.5 is right here. Okay. So we're going to be between these two things. You have to be greater than 3.5, but less than 4.5. That's what your graph would look like, your number line. How would you write it in interval form? When I mean interval form, I mean like this. Yep, 3.5 to 4.5. This is how you write it in interval form. So your thickness can be as low as 3.5 or up to 4.5. All right? So that was a real world application to when we were doing these absolute value solving problems. All right.